In this research, we present a lightweight, wearable haptic force feedback glove designed to improve robotic teleoperation. Traditional haptic gloves rely on electric or pneumatic actuators that are bulky, heavy, and often uncomfortable for long use. To overcome these issues, our glove uses a cylindrical electrostatic clutch as the main actuator, coupled with a flexible rack and pinion finger tracking mechanism. This unique combination enables smooth finger motion, precise tracking, and consistent force feedback, all in a compact and low-power design. The glove was modeled using SolidWorks and fabricated with 3D printed components. The electrostatic clutch, only 13 grams in weight, provides a maximum force of 3 newtons at 1000 volts, while maintaining excellent repeatability and low response time. The glove was then integrated into a teleoperation setup where users controlled a 3D printed robotic hand to grasp objects while receiving realistic feedback. 20 healthy participants evaluated the system. Results showed high satisfaction for weight, comfort, and ease of use, with average ratings around 5.9 out of 7. Statistical analysis revealed no significant difference between male and female participants, confirming consistent performance across users. This work demonstrates the potential of electrostatic clutches for lightweight and safe haptic systems. In future, we aim to extend control to all 5 fingers, add wireless communication, and enhance feedback realism for applications in virtual reality, teleoperation, and rehabilitation.
For more details about this project, I have included a link in the description for the full open access research publication. Feel free to read it to gain further knowledge. Please subscribe to my channel, Kicker at TechGo, and hit the bell button to receive notifications. Additionally, I would greatly appreciate it if you could like, comment, and share the video. Thank you for your support.